The most famous supernova explosion occurred in 1054, and we can still see the remnants of this explosion as the Crab Nebula. At the centre of the nebula is a pulsar. This is a rapidly rotating neutron star whose enormous magnetic field is producing beams of radiation that are fired from the magnetic poles of the neutron star. And the neutron star spins like a cosmic lighthouse, and each rotation, when the beams point in our direction, we see a pulse of radiation. The rapid spin of the neutron star slows gradually as it loses energy in these pulsar beams, and after about 1 million years the neutron star no longer has sufficient energy to power the beams. So the pulsars fade and the neutron star disappears from view. It's difficult to conceive just how small neutron stars are. With a diameter of 20 miles or 30 kilometres, which is about the size of a major city, they might sound quite large, but we need to remember that the mass of a neutron star is greater than the mass of the Sun. So this animation compares the size of a neutron star to the size of the Earth and the Moon. With a mass of at least 1.5 times the mass of the Sun, the neutron star has over 500,000 times the mass of the Earth. Not all collapsing stars result in the creation of a neutron star. There is a maximum mass that can be supported at nuclear densities, and although we don't know precisely what this maximum mass is, it must be about 2.5 times the mass of the Sun. So for really huge stars that come to the end of their life, when they collapse, there is nothing to halt the collapse, and the result is the creation of a black hole. One of the prime candidates for a star that might go bang in the very near future is a star known as Eta Carinae that's visible from the southern hemisphere. This star can be found in a star-forming region that is noted for its X-ray emissions that show that this has been the home of numerous supernova explosions in the past. Eta Carinae is a double star with two huge stars orbiting each other. The main star has a mass of about 100 to 150 times the mass of the Sun, and the second star has a mass of about 60 times the mass of the Sun. And it's been estimated that this star system has already lost about 30 times the mass of the Sun. Just over 30 years ago, in 1987, there was a supernova explosion that could be seen with the naked eye in the southern hemisphere. This supernova explosion occurred in the Large Magellanic Cloud, which is a dwarf galaxy that orbits our Milky Way galaxy at a distance of about 170,000 light years. The supernova was produced by the collapse of a blue giant star, and this can be seen in this image here before and during the eruption. And the identity of the star has been confirmed because the original blue giant star is no longer visible. Astronomers have searched for the neutron star or black hole that we might expect to have been produced by the supernova explosion, but as yet no such compact object has been identified. And we can see here in this image the shock waves from the supernova explosion colliding with an illuminating material that was previously emitted by the blue giant star. Two to 3 hours before the light from this supernova explosion in 1987 became visible, a burst of neutrinos was detected at 3 neutrino observatories around the world, in Japan, the United States and Russia. There were a total of just 25 of these elusive particles detected, but these were the first neutrinos ever detected that we know came from outside the solar system. One of the detectors was the Kamiokande detector in Japan. A neutrino detector is essentially just a vast pool of liquid surrounded by extremely sensitive detectors. But neutrino detectors have come a long way since 1987, and the neutrino detector in Japan is now known as the Super Kamiokande detector. It's estimated that a supernova explosion occurs in our galaxy once every 30 years or so. But most of these supernova explosions are hidden by clouds of interstellar dust. However, the next such supernova explosion won't go unnoticed, because even if we can't see its visible light because it's shrouded in dust, its vast neutrino flux will be detected. The supernova will produce vast amounts of neutrinos, and a modern neutrino detector such as Super Kamiokande can expect to detect about 1 million neutrinos from such a supernova event. So, although a star such as the Sun will end its days as a white dwarf, a monster such as Betelgeuse or Antares has a much more dramatic fate to look forward to. These stars will end their lives in supernova explosions that will seed the galaxy with the elements of life, and their core will remain compressed into a neutron star or a black hole.